All right, so we're just going to continue 1.4. This is like 1.4b if you want to label it. But now we're going to talk about adding and subtracting radical expressions. Okay, so let's start out with 2x over x minus 5 minus 5 over 5 minus x. Alright, so let's go back in our memory all the way to 4th grade. When you add or subtract fractions, what do you need? A common denominator, right? So we have to get a common denominator here. So in order to do that, you want to think about, that LCD. However, we almost have one, right? If we were to factor out a -1 here, we would have that x minus 5 we need. So that's what we're going to do first. So this is really like negative times x minus 5. Now, here's where students make a mistake. This negative sign is really like out front here, right? So it's like a minus and a minus. So this is really becoming an addition problem now. Okay, so I'm going to rewrite this. So I have 2x over x minus 5 plus 5 over x minus 5. Remember, when you are adding fractions, once you get that common denominator, the denominator stays the same and you just add the numerators. Okay, so this is going to give us 2x plus 5 over x minus 5. With these, you don't have to list the restrictions. See, nothing's canceling here. We're just putting more stuff in sometimes, right? We're creating a bigger denominator at times. So, with that being said, you don't have to worry about a restriction because nothing's going away. We can see here that x can't be 5. So, this is it. Okay? Nice and easy to start out. All right, let's try this next one. X over x squared plus x minus 2 minus 2 over x squared minus x minus 6. Okay, so the first thing I want to think about is that common denominator. Okay, so before I can get that, you could multiply these two together, right? But there's probably a smaller denominator if we factor it. So that's what we're going to try to do. So we have x plus 2 times x minus 1. Right, here we get x minus 3 times x plus 2. So now what I notice is I have this x plus 2 factor in common. Okay, so I don't have to worry about that. Over here I'm missing an x minus 3, right? And on the right side I'm missing an x minus 1. So that's what I'm going to multiply by. So my common denominator is going to be x plus 2 times x minus 1 times x minus 3. So this piece needs an x minus 3. Remember, you have to multiply it in the numerator and the denominator. And on the right side we need an x minus 1. Now here's another note. This was a minus, okay? We really need to be careful that, thank you, this gets distributed to that 2, all right? So I'm just going to make myself a note here. This is really like a -2, okay? Because you want to make sure this -2 gets distributed to both of those terms. So now in the numerator I'm going to have, sorry, x times x minus 3. You can write plus a -2. You can write minus 2 times x minus 1. Okay, it doesn't matter as long as you remember what to do there. And then that's all over our common denominator. I'm sorry. Okay. So now let's distribute in the numerator and see what happens. x squared minus 3x minus 2x plus 2. It's not done. Okay, I know, watching the video. So now if we combine these like terms, we get a negative 5x here. Most likely that numerator is not going to factor, but it's always good to check. Okay, so we get x squared minus 5x plus 2 over x plus 2 times x minus 1 times x minus 3. Again, notice there is no restriction needed to list because we can see all of those pieces, nothing canceled. Okay, everyone okay there? Okay. I'm going to give you one to try with your partner. I think we can fit it here if we just move this up. So 2 over x plus 1 plus 2 over x minus 1 plus 1 over x squared minus 1. All right, so you and your partner talk about that. All right, so did you start by factoring x plus 1 times x minus 1, that difference of perfect squares? Okay, so then hopefully you recognize that the first term needs an x minus 1. The second term needs an x plus 1. And then we already have that common denominator on the right. Okay, so now we're going to get 2. I'm going to distribute while I go. So 2x minus 2 plus 2x plus 2 plus 1 all over. You can either write it as x plus 1 times x minus 1. You could write this one as x squared minus 1. I'm fine if you leave it in factor form because it's a lot faster for me to check. Okay, so that's how I would prefer you do it. Here the 2's are going to cancel. We get 4x plus 1 over x plus 1 times x minus 1. By show of hands, how many people got that? Okay, excellent. So we're okay on these. Can we move on to the next topic? Okay, so that's okay. We know how to add and subtract fractions then. The next piece is a little bit more complicated. So we're going to talk about compound fractions now. We saw one yesterday. So a compound fraction is basically fractions with fractions in the numerator and denominator. Okay, in order to simplify them, you're going to multiply the numerator and denominator by the LCD, the least common denominator. Okay, so let's take a look at this. 1 plus x over x plus 1 all over 1 minus x over x plus 1. Okay, so sometimes these can be a little bit intimidating because there's lots of fractions going on, all right? So what you want to do is you want to think about what is the LCD, what's the least common denominator I can multiply in the numerator and the denominator, which will therefore cancel that compound fraction, just creating a single fraction. So looking at this, first of all, when I see this 1, I'm thinking it's like 1 over 1. Any whole number, you know, you can put over 1. Okay, make it a fraction. So there's what I'm thinking. Okay. Now in terms of like a common denominator, wouldn't it just be x plus 1? So what I can do is I can take that common denominator and I can multiply it in the numerator and the denominator by it. So I'm going to take this numerator, I'm going to multiply it by x plus 1. I'm going to take the denominator and I'm going to multiply it by x plus 1. Yes?
You have to multiply the terms that already have it as a denominator?
Yes. You have to distribute it through. So now when you do that, okay, 1 times x plus 1 is just going to give me x plus 1. Okay. Now the second term, we have an x plus 1 in the denominator and an x plus 1 in the numerator now, right, when you distribute it. So those cancel and I'm left with just plus x. You might want to write off on the side what we're doing here. So like 1 times x plus 1, and then we're doing x over x plus 1 times x plus 1. Then in the denominator, we're going to do the same thing. So I'm going to have 1 times x plus 1 minus x over x plus 1 times x plus 1. And then maybe you can see that canceling happening a little bit easier. So here the x plus 1's canceled. I was left with just the x. In the denominator, I'm going to get an x plus 1. And then again, that second term is going to cancel the x plus 1, leaving me with a minus x. Bless you. Okay, now I want you to make yourself a note, because this is another common mistake made by students, major legal stamp. So many people want to try to cancel this x plus 1 and this x plus 1, right? They line up one right under the other. It just seems like the right thing to do. You cannot do that because this is addition and subtraction. The only way to do that is through multiplication. So you want to take the time to simplify now. So I get 2x plus 1 over 1, which is just 2x plus 1. But now you got to go back to the beginning, right? Because there was canceling that happened here. So you want to see, was there a restriction that went away that I can no longer see? And that would be that x can't equal negative 1. Okay. So if you can't go from this step to this step right now, that's okay. Just take the time to write this out. It might be easier to see that way. Okay? Ready to try another one? Okay. 1 over x minus 1 over y all over 1 over x plus 1 over y. So we're looking for a denominator that's going to be able to cancel out all of our denominators. Okay, so what would that common denominator be? xy, right? X times y. So I'm going to multiply in the numerator by xy and in the denominator by xy. If you need to write it out on the side or as a step, that's fine. So I have to distribute it here to my first term and to my second term. So when I have 1 over x times xy, I just get y. 1 over x times xy, the x's cancel, you're left with y. When I distribute it to the second term, the y's are going to cancel, and I'm going to be left with a minus x. Over, here I have to distribute it, so xy times 1 over x and xy times 1 over y. Here I'm going to get y plus x. Can you cancel anything here? It'd be tempting to, though. Okay, don't let it tempt you. There is a restriction. X can't equal 0 and y can't equal 0. Yes?
I know you're not supposed to write it, but isn't that's not allowed to be negative y?
That's true. You can write it, you just don't have to. There is another way to do this problem. Okay, all these problems. You could get a common denominator in the numerator and a common denominator in the denominator, and then you could multiply by the reciprocal, like we did yesterday when we were dividing. Okay, so there is another way, but this is the fastest way to do these problems. Yes?
You have to have that x equal 0.
You do, because those were the restrictions from the beginning that canceled.
Isn't it still the same though at the end?
Well, they both can equal 0 at the same time, but x could be 0 here, right?
Yeah.
That's where that restriction of, you know, x can't equal negative y would come in, but we don't have to list that one. Okay? Yes?
When you're writing these from least to greatest, what it can't be, would the letters go after the numbers?
Here I won't really care about that. Yeah. Any other questions on B? Okay. Let's try another one. 5 over y minus 6 over 2y plus 1. Yes? Oh, I'm sorry. If you were to set this piece equal to 0 and think about solving for x, you'd subtract over the y. So if x equals a negative y, like if x is 2 and y is negative 2, and you add those together, you're going to get a 0 in the denominator. All right, now, then we're going to have 5 over y plus 4. Okay, so again, I'm thinking about the fact that this 4, I'm going to make a fraction. I'm just going to put it over 1. Now I have to think about the common denominator. So what's the common denominator? What's the LCD I'm going to multiply by? Y times 2y plus 1. You have to do that in both the numerator and the denominator. You have to distribute it to both. If you're having trouble seeing it, write it out. Okay, write out 5y times 2y plus 1 over y, and then watch the canceling. Do you want me to do that? Okay, so if I do that, I'm going to get 5y times 2y plus 1 over y for my first term. Then my second term is going to give me minus 6y over 2y plus 1 over, oh, here, okay, I see where I'm writing out the whole thing, over 2y plus 1. Okay, now I have to do it to the denominator. So when I do that, I'm going to get 5y times 2y plus 1 over y and plus 4y times 2y plus 1. Now you might be able to see that canceling happening a little easier. So here the y's cancel. Here this 2y plus 1 cancels. Here this y cancels. And then nothing is needing to cancel here. This leaves me with 5 times 2y plus 1 minus 6y over 5 times 2y plus 1 plus 4y times 2y plus 1. Okay, now you might be able to go from here to here. That's fine. You don't have to show this step, but if it helps you, then do that. Okay, so now we just have to simplify this. So I get 10y plus 5 minus 6y over 10y plus 5 plus 8y squared plus 4y. I need to combine my like terms. So 4y plus 5 over, let's see, 8y squared plus 14y plus 5. So here's the bad part. Looking at this denominator, there is a chance that this could factor. Okay, so I want to see if it will. It does, which is unfortunate for us, but that's okay. So this will factor to 4y plus 5 times 2y plus 1. And at that point we can see canceling. Right, we have this common factor. It can cancel. Final answer should be 1 over 2y plus 1, where y can equal not negative 5/4. Go all the way back. Y can't equal 0. You have to go back to the original. Okay, see, because at this point we've manipulated this with a common denominator and everything, so we don't want to pay attention to that piece. You want to go all the way back up to the top and see what canceled, where and y cannot be 0. The negative 1/2 is obvious still, so we don't have to list that piece. Okay, so if you got to here, and then you didn't take it further, it'd probably be like minus 1 or 2 points. Okay, this would be a lot of points for this problem. This was a lot of steps. All right, so this would probably be like a 5 or 6 point problem on a quiz or on a test. So if you don't take it further, you know, minus 1 or 2. Okay? Just so you know. You think you're ready to try one? Okay. How about 1 over x minus 1 over x plus 1 over 1 over x plus 1? Did you multiply by x times x plus 1? Okay, so when you did that, you should have got x plus 1 minus x over x. These x's cancel. We're left with 1 over x. The restriction you have to list is that x can't equal negative 1. By show of hands, how many people got that? Okay, nice. All right, this is good. All right, so if you need a couple extra steps, it's fine. We have one more to go. We're going to do it together. Might as well throw in some radicals. It'll be a good time. Feels intense. Let's think about this for a second. First of all, like this 3/2 power is really like a radical, right? This is the same as if you had the square root of 4 minus x squared cubed, right? So let's just keep that in mind. Okay, so right now, this is over 1. And so is this piece, technically. Right? So there's our compound fraction. The rule to simplify a compound fraction is that you're going to multiply by the LCD. So looking at these 3 denominators, what's that common denominator? The square root of 4 minus x squared. So that's what I'm going to multiply by. So 4 minus x squared. Okay, now, what happens when you take a square root and you multiply it by itself? The root cancels, right? Because you're creating a perfect square. Root 2 times root 2 is just 2. So that means that the square root of 4 minus x squared times the square root of 4 minus x squared is just 4 minus x squared. Okay, so again, you have to distribute it to all of them. Looking at the second term, I have one radical in the numerator. I have the same radical in the denominator when I multiply these. So what's going to happen there? They're going to cancel, leaving me with just plus x squared. All over. All right, now let's think about this. So this is written as a fractional exponent. Let's write this one as a fractional exponent. It's the same thing if we write 4 minus x squared to the 1/2. Don't those mean the same thing? When you have bases that are the same and you're multiplying them together, what do you do to the exponents? You add them. X squared times x cubed, you add exponents to get x to the 5th. Well, our bases are the same. 4 minus x squared, 4 minus x squared. So all we have to do is add these exponents. 3 halves plus 1 half is 4 halves, which is just 2. So 4 minus x squared squared is what is left over. This just got a lot easier. The radical went away, and that compound fraction went away. Now all I have left to do is to simplify. So I get 4 over 4 minus x squared squared. We have not talked about how to solve something like this yet for domain, so we're not going to worry about the restriction here. That's way too much right now. Okay, so even though it looks complicated, we still use the same process. Sometimes you have to think about it like a fraction, sometimes you have to think about it like a radical. Yes?
Okay, I'm sorry. Can
Sure.
you restate how you got the denominator? Because you're lost.
How I got this,
The denominator.
this?
Yes.
Okay, so here I'm multiplying by that LCD of the square root of 4 minus x squared. I just wrote it as a fractional exponent. Okay, so the square root is the same as a half. So now all you have to do is add exponents. So 3 halves plus 1 half gives me 4 halves, which is 2. Okay? Brittany? Negative x squared plus x squared cancels. Yes?
Why?
Josh?
Final answer. Couldn't you change the 4 into 2 squared and then you take out this square on both the top and bottom?
No, because of subtraction. Okay? What else?